Okay, so a little bit more of the graph sketching. So this time we're going to look a little bit about what happens in terms of if we have that little translation inside the bracket. Normally it's the little epsilon there represents an angle that we normally add and subtract, okay? Now my format hasn't come out particularly well, but that's just the pi symbol it's meant to be. Oops. So what happens if we have t plus or minus pi on 4? Okay, so we know that just translate our graph left and right. Negative inside, we go to the right. Positive inside, we come back to the left. All right. So in terms of sketching these, first step is always just do your period and your amplitude. And again, I'm not convinced that necessarily having um, the grid listed for you is necessarily the best thing, but we'll see how we go. So let's first things first, right? We've got a 2 theta there. First step is always get the coefficient of, now it doesn't matter whether it's x or y or whatever the graph we're looking at, get it to be 1. So sine of 2, let's take the 2 out the front, we get theta minus 90 degrees. Okay, so straight away, instead of the graph shifting 180 degrees to the right, we actually see that it's only moving 90 degrees to the right. Period of my graph is given by 2 pi on n, which is 2 pi on 2, which is equal to pi, which for us is 180 degrees. Okay, the amplitude hasn't changed, it's still 1. So first things first, your initial graph, sketch those two, sketch your period and amplitude graph. Okay, so the amplitude is 1, so there's 1 there, there's negative 1 there. And the period is 180. So we get start and finish by 180. There's 90. So it's a sine graph. I'm going to come up to 90, come down. There's one cycle. We're to go to 360. It's probably not a bad thing to do both cycles. So there's 360 there. There's my halfway mark there. So we can see the maximums are sort of at the key points. Okay, so that's just, so that graph is sine 2 theta, all right? We now want to shift everything 90 degrees to the right. So because we're going to move everything 90 degrees to the right, it probably makes sense to bring our graph out to there at negative 90, because now everything moves forward 90 degrees. So what I'm going to do is just going to put a little cross at, there's my 0 starting point there. Well, I'm going to bring it forward 90 degrees to start there. That point goes forward 90 degrees. That point goes forward 90 degrees. That point goes forward 90 degrees, which will be too far. So the 270 goes to there. That point comes to 0. This point here comes forward 90 degrees to there. That point there goes forward 90 degrees to there. So you can see that my graph really, once you get your first few points in, you can see what's happening. It's just everything shifted forward 90 degrees. So the blue graph is my actual function. So let's write that as sine 2 theta minus 90 degrees. Okay. Okay, so similar thing. Let's have a look. Period of the graph is 2 pi on n, which in this case is 2 pi on 3. And we've got to shift to pi on 6. The amplitude hasn't changed. It's still 1. So it's a cosine graph. So the amplitude is 1. So we're going there. And 2 pi on 3 is a period. So 2 pi on 3. So I get finished and back by there again. So what I've got to do is I've got to come down and up and back. So look, I think what we might do here, let's change our scale a little bit, I reckon. But it's just too tight. So let's, instead of, I wonder if I can do that. How good am I? Let's try that one. No. Oh, that's disappointing. All right, never mind. So let's go with, let's just double everything, hey? So let's make this, might get messy on us, pi on 6, pi on 3. So that becomes 2 pi on 3, and that's pi on 2. All right. So at least that way, we know that the period is 2 pi on 3, so it gets back to there to there. We're down there, so we can go down, up. Leaves a bit more space for us, all right? We're shifting it to the right, so again, let's go that way, all right? Now we're shifting everything. Now I've got to shift everything to the right, pi on 6 units. So let's remember a couple of things. Pi on 3 is the same as 2 pi on 6. Pi on 2 is 3 pi on 6. 2 pi on 3 is 4 pi on 6. So all we're doing is moving each of these spaces here, they're pi on 6. So if I just put a blue cross again, I'm moving that point there to there, that point there to there, this point here to here, that point down there to there, that point there across, this point here across. So I'm just sketching there to there to there. Now I could sketch it through to there, I guess, and that point there is there. But because our domain is just 0 to 2 pi on 3, we don't need that section, and I don't need that section. All right. And again, in this case, if we're just sliding left and right, we can see what my values of my intercepts are without necessarily doing any calculations. All right. Get to it.